So this is lesson 4, number 13. It says, in the system below, the 2 kilogram mass moves with the 12 kilogram mass. In other words, they accelerate together as a system. Find the acceleration of the system and then find the minimum coefficient of friction of the 2 kilogram mass. Ooh. Well, first of all, this is a job for a free body diagram. I think to find the acceleration of the whole thing, because these two move together, I'm going to treat this as though it's one big 14 kilogram mass for the first part. So I'm going to do a free body diagram. M1G, normal force, tension, no friction here. M2G, tension. And so I'll end up with M2G minus tension plus tension equals M all A. Tension cancels. A ends up being M2G divided by M all, which is going to be M1 plus M2 plus M3. It's going to be 8 times 9.8 divided by 2 plus 12 plus 8. And now I'm going to fix my diagram and go back to a 2 and a 12 for the second part. But for now, it's going to be 8 times 9.8 divided by bracket 2 plus 12 plus 8. And that's where the 3.6, actually 3.5636 repeating comes from. So I'll write 3.5636 meters per second squared. Then it wants me to find the minimum coefficient of friction between the 2 kilogram mass and, I guess, the 12 kilogram mass. Well, again, I guess it's a job for a free body diagram. So let's zoom in on the 2 kilogram mass. We'll call this part B. Here's the 2 kilogram mass. What are the forces acting on it? Definitely mg down, normal force up. Which way is the 2 kilogram mass accelerating? Well, it says the 2 and the 12 accelerate as a system. So if the 12 is accelerating to the right, the 2 is accelerating to the right, which means there has to be a force pointing that way. And the real question is, what force is that? Can't be tension because the rope is not touching the 2. And then I thought to myself, well, if right here between the 2 and the 12 was pure ice, the 12 would get yanked right out and the 2 would just drop straight back down. I said, you know what is helping the 2 kilogram mass move forward? Friction. That's got to be the force that's pulling the 2 kilogram mass forward. And so the equation I'm going to get is friction equals ma. Winner, no loser, equals ma. Mu times the normal force. I don't know the normal force. Oh, but look. Mu mg equals ma. Ooh, cool. There's an m in everything, so the mass actually cancels. Now they wanted me to find mu. I guess to get the mu by itself, I'll divide by g. And I'll end up with mu equals a divided by g. It's going to be 3.5636, but I'm going to use my answer button. Divided by 9.8. And I get 0.36 repeating. Units, mu, the coefficient of friction, has no units. It is a unitless or a dimensionless quantity. So that's kind of a neat question. The actual equation you get is really about as simple as it comes, but spotting that friction is what's pulling the 2 kilogram mass forward. That's the aha moment. So if you got that, be proud of yourself, because that's a pretty tricky question.